Well, hello everyone. Again, this is part 4 of the tension steel member. So we've talked about some good information about how we analyze the steel members as elements in the building structure. And today we're going to look at example 9.3. Example 9.3. It's a continuation of examples 9.1 and 9.2. In those examples, the previous two examples, we looked at how to find the net area and then the effective area. Now, why did we have to find those? Because we're going to use them in this example so we can find the design strength. Why do we have to find the design strength in this problem? Because we want to understand this angle steel, if it's going to fail, and what kind of mood failures that we'll be dealing with, so we can design for that failure so it won't fail, if that makes sense. In other words, we design against the mode of failure. But first, we have to identify the mode of failure first, then we have to design for it. So it's kind of in reverse, if you will. So let's read the problem statement first. What is the design strength of the element of example 9.1 for A36 steel? This is the steel type, and they want us to determine the design strength of this type of steel. Like we said, we find the net area, which is 3.7. We find the effective area, which was 2.223 inches as the effective area. And now we're gonna have to find the design strength. So if I take you back to slide number 9, we said to find the design strength at the tension scenario, we have to find the yielding at the gross section, and then we have to find the rupture at the net area and see which one is smaller, and that controls. In other words, whichever value is smaller is the one that's going to fail first. So now we want to determine if the failure is going to be through rupture or going to be a yield in the section area, in the gross section area. So for the gross section area, the yielding is the PU, which is the ultimate tensile load strain, 0.9 times Fy times the gross area. And for the rupture at the net area is the PU 0.75 FU, which is the ultimate strength times the effective area. So if we go back to our problem here, the first one is 0.9, which is the yielding at the gross area, times Fy times gross area. So it's 0.9 times 36 Fy, right? The type of steel, 36 times the gross area, which is 4.79 given in the problem statement. And that gives me 15309 kips. Then the second one is the ultimate, the rupture at the net area, which is 0.75 times FU times effective area. So it's 0.75 times 58, and that's the ultimate value, times 2.21, and that gives me 96.14. Now, where did we get the 58 from? Now, for this type of steel, if you go to, I think, table 9.1, page 176, common steel grades. So if you look at the ASTM classification, you have A36, and it gives you the FY is 36, and for FU is 58. So it's from this table here. Even if it's not given in the problem statement, you should find it from this table, this 58. So then that gives you this value. So this value here is lower than this, which means this value controls. In other words, the mode of failure is going to be at rupture first before the yielding at the gross area. And this is what it means. So for that, I'm gonna stop here and thank you.